In this video, I'm going to give you a quick introduction to ions and writing formulas for ionic compounds. Now you may know that if we were to vary the number of protons in an atom, that actually changes what the atom is. So if you look on the periodic table, the first element is hydrogen. Hydrogen has 1 proton. The second element is helium. Helium has 2 protons. The third element is lithium. Lithium has 3 protons, and so on and so on and so on. What you can't say is, I have a lithium atom with 2 protons. That doesn't make any sense. Lithium must have 3 protons in order to be lithium. If it only had 2 protons, it's not lithium, it's helium. So proton, you can kind of think of the number of protons as like the identity of the atom. Now, the other subatomic particle is the neutron. Whoops. And if we vary the number of neutrons within a particular element, that gives rise to isotopes. So, our last subatomic particle is electrons. So electrons are what we're going to be really talking about today. Varying the number of electrons creates ions. So our first example is sodium. Now you'll notice here in the nucleus I have 11 plus, and that's signifying the fact that there's 11 protons in the sodium nucleus. And then I have 11 electrons surrounding the nucleus. This is the neutral sodium atom, and the symbol for that is Na. What happens is sodium can lose 1 electron and it becomes the sodium ion. So notice the difference here. We had 11 electrons here, we lost 1, now we only have 10 electrons. But notice what stays the same. 11 protons in the nucleus before, 11 protons in the nucleus after. So we lose an electron to create the sodium ion, and we write that symbol as Na plus. That plus is signifying that there's 1 more proton than there is electrons. Alright, so if we were to write this out more as a formula, less visually, we would write Na yields Na plus an electron. Now, these positive ions, these are called cations. So a cation is a positive ion that is produced when 1 or more electrons, and this is a symbol we use for electrons, it's an E with a negative sign, when 1 or more electrons are lost. So these are cations. You're losing electrons, so you're creating positive ions. If we take another example, magnesium. Nucleus has 12 protons before and after. You see how many electrons it loses. It has 12 electrons before, only 10 afterwards. So it loses 2 electrons. Our symbol for our neutral magnesium atom is just Mg. Magnesium ion would be Mg, and now it lost 2 electrons, so we'd write 2 plus. So if we were to write this out as a formula, we'd say Mg yields Mg plus 2 electrons. Okay, our next example is with aluminum. Aluminum has 13 protons before, 13 protons after. It has 13 electrons before, only 10 electrons afterwards. So it loses 3 electrons. Our neutral aluminum atom is Al. Our aluminum ion is Al 3 plus. We write that out as a formula. We'd write Al yields Al 3 plus 3 electrons. Okay, so notice you might have seen the name change that is occurring here for the cations. Before we had aluminum, and then after it's an ion, it's just called the aluminum ion. So all we do with cations is we just write the word ion at the end. Okay, now what we're going to do is take another example, but notice what's happening this time. We had 17 electrons before, and now we have 18 electrons. So we're actually gaining electrons, so we're adding 1 electron here. So it's chlorine before, chlorine after. We know that because it has 17 protons before and after. So let's think about how our symbol changes. So neutral chlorine atom would just be Cl. The chlorine ion would be Cl minus. And if we were to write out this as a formula, we'd say Cl plus an electron yields Cl minus. And these are called anions. An anion is a negative ion that is produced when one or more electrons are lost from the neutral atoms. And there's a name change that occurs here. We wouldn't really say the chlorine ion here. Really, what I should have written is the chloride ion. What we do is we take the ending, that INE, and we change it to "ide." So if we're talking about fluorine, it wouldn't be the fluorine ion, it would be the fluoride ion. Oxygen would be the oxide ion. So whenever we're dealing with anions or negative ions, we change the ending to "ide." Alright, so we've learned briefly about ions. They're just, they're either positive or negative, cations or anions. Now I want to talk about actually combining them in order to form compounds. So ionic compounds are formed by a metal and a nonmetal. What tends to happen is the metal loses electrons and the nonmetal gains electrons. So if we lose electrons, that means we're becoming positive, so the metal tends to be the cation. And the nonmetal tends to be the anion. And this next thing is really important. The compound that is produced is neutral. And the number of electrons that the cation loses has to be equal to the number of electrons that the anion gains. Now, there's some ions that you should know, and this periodic table I have here is a little bit small for me to actually write them all in, so I'm just going to kind of highlight some different areas of the periodic table and the ions you should know. These right here, you should know that these are all +1 cations. These ones right here, they form +2 cations. Move over to the right side of the periodic table. These noble gases here, they don't really form ions, so we're going to move over to the next column. So these are the halogens here. These form -1 ions. And then we'll move over here. These tend to form -2 ions. And then you should know that these two right here, nitrogen and phosphorus, they tend to form -3 ions. And then finally, these three right here tend to form +3 ions. So based on their placement on the periodic table, you can know what charge they might have. And we'll talk later, in a later video, about other ions, and it might not necessarily be as obvious as to what their charge is. You can't just look at the periodic table, every single element, and determine what the charge is. So we'll talk about that in a later video. Alright, so I want to go through some examples. The first one we'll do is sodium plus chlorine. So if you have a periodic table in front of you, you'll see that the sodium atom is right here. So that means that it forms 1+ ions. So we're going to write Na+. And then again, if you have a periodic table in front of you, you'll see that the chlorine atom is right here. So it forms Cl-. So what we need to do is we need to make a neutral compound with this. So what that means is you take one, the way you should go about doing this is you should take one of each and you should add up their superscripts. So we have a +1 and a -1. And that value comes out to 0. So what that's telling us is in order to form a compound with sodium and chlorine as the atoms, we need to have 1 sodium and 1 chlorine. And we would name this compound sodium chloride. Okay, let's try barium plus oxygen. So barium is down here on the periodic table. So we know that that second column produces 2+ cations. And oxygen is right here on the periodic table. So we know that it produces 2- ions. So again, we add up their charges. We want to get to 0. So +2, -2, that is 0. So our formula is just BaO, barium oxide. All right. Let's do the next one, potassium plus sulfur. So if we look for potassium on the periodic table, we see that it's right here. So that means it forms a +1 ion. And if we look for sulfur on the periodic table, it's right below oxygen, so it forms a -2. So we have potassium +1 and sulfur -2. So we take one of each, add up their charges, and we get overall a -1. But that's not 0, and 0 is our goal. So what you need to think about is if you need to make this number if you need to make that number 0, should you add another potassium or another sulfide? Those are your only two options. So we want to get this number to 0. So in order to get that number to 0, I would add another potassium. So now I have 2 +1s, so we could say +2 overall. And then we have 1 -2, so -2. So a +2 and a -2 makes this 0. So the formula for this one would be K2S, or potassium sulfide. All right, let's try the aluminum plus oxygen. The aluminum ion is Al3+, oxygen is O2-. So let's add up their charges, and we get +1, so not 0. Our only options are to add another Al3+ or another O2-. I want to get to 0, so I'm going to add another O2-. Add up these three charges, we have a +3, a -2, so +1, and then another -2 makes this number into a -1. So again, not 0. Okay, I want to get to 0, so I'm going to add another aluminum. So we have 2 Al3+, so we can kind of think of that as 6+ overall. O2- twice, so that's 4- overall. So I'm going to write that down here. We have a 6+, and we have a 4-, so you can kind of think of that as 6 - 4. That's +2, so it's still not 0. Alright, we want to get to 0, so I'm going to add another oxygen. So now we have 2 3+, so that's like a 6+ overall, and we have 3 2-, so it's 6- overall. So now we're at 0. So the formula for aluminum oxide would be Al2O3. Okay, there's a couple more things I want to point out before we'll be done with this video. One thing is, even though we might not know a particular ion, we should be able to determine it based on the other ion in the compound. So let me give you an example here. If I had the example, let's say I have Na2X. So X is just signifying an unknown ion. I could ask you, well, what is X? What is the element X? Or I could just ask you, what is the charge of X? And you should be able to answer both of those questions. So what this Na2 is telling us is we have 2 Na+ ions. So that means a +2 charge overall. So that means this over here is a -2 charge. So even though we don't know what element it is, we know it has to have a -2 charge. So if you were asked, well, what is that element, you could say a couple different things. You could say, well, I think it's oxygen, because we know that the oxygen makes the oxide ion, the O2-. Or we could say, I think it's the sulfur, which makes the sulfide ion, S2-. So even though we didn't know this exactly, we figured it out based on the other piece of information. So let's think about this one right here, FeCl2. I want to know, what is the charge of iron? Well, we don't know necessarily the charge of iron based on the ones I gave you, but we do know that chlorine is -1, and we have 2 of them. So that means -2 overall for this piece. So that half of the equation, or the formula, needs to be +2 overall. So we can say that iron must be a +2 cation in this formula.